Warm greetings, learner. Myself, Dr. S. Sengalrani, Associate Professor, Department of EEE, Velamal College of Engineering and Technology, Madurai, will be presenting a topic, Application of Operational Amplifier as Peak Detector. The content for today's discussion is, what is a peak detector, how signal peak can be trapped, whether positive and negative peak can be trapped by this circuit, and where it is used. We'll get into the definition of a peak detector. So as the name indicates, it is very clear that it is some detecting circuit which will be detecting a peak value. The peak value of the applied signal, it will be computed by this peak detector circuit. So you will have more than one peak in a signal. Assume that you are having more than one peak signal in the applied input. So each and every time when this peak detector tries to detect, it will store the highest value. So when another highest value is coming along with the input, the previous highest value, it will be erased and the new highest value will be stored inside the capacitor. So this is how the circuit it will work. We'll start our discussion with a positive peak detector. So here I have used an active element, an operational amplifier, for computing the peak of an input signal. So here the circuit, it is more or less resembling a voltage circuit pattern, where in that voltage follower circuit you can find that a diode has been inserted. So this diode, it will act as a switch here. Depending upon the applied input and depending upon the charge that is stored in the capacitor, the diode will be either in off or on condition. Depending upon the on and off condition, this circuit, it will behave as a voltage follower, or it will retain the charge that is stored inside the capacitor. So this is how the circuit it will work. So we will start our discussion with what happens when Vin it is less than Vc. So when Vin it is less than Vc, you can find that this Vin it is connected to the non-inverting terminal of an operational amplifier. So assume that you are having a positive value. That positive value it will be applied here. And here on another end, we have the charge that is stored by the capacitor. So the charge that is stored by the capacitor, it will dominate the charge that is being provided at the input side of the diode. So here anode, it will have a minimum voltage when compared to the cathode. So here the relation itself, it says that when Vin it is less than Vc. So assume that here it is 5 and on this side you are having 10. So when 10 volts it is applied here, this 10 volts it will dominate the operation. So here cathode it is receiving a higher value when compared to the anode. So this diode it becomes reverse bias. So reverse bias, it means that the diode it will be under off condition. So when the diode it is under off condition, this operational amplifier it will be disconnected from the output terminal. So the entire charge that is stored in the capacitor, it will be taken as the output. So the previously stored charge, it will be taken as the highest value of this circuit. On another case, it is when Vin it is greater than Vc. So here the applied input, it is dominating the operation of this PN junction diode. So anode it will be greater when compared to the cathode voltage. So this side the voltage, assume that it is 5 and this side you assume that it is some 4. So this 5 it will dominate this 4, so that this diode it will be under forward bias condition. So this forward bias condition, it means that the diode it is under on state. So on state it creates a closed circuit in this path, and this closed circuit path it will make the circuit to behave as a voltage follower. So what a voltage follower does, whatever you apply here, that value it can be found at the output. So whenever the condition Vin it is greater than Vc, you can find that the detector circuit it acts as a voltage follower. So whatever you have here, the same value it is found at the output. So this is how the operation it will be. And the output of the peak detector I have shown here, you can find that the output it is having more number of peaks here. So here the highest peak alone it will be given to the output signal. So here these are the charges that will be held inside the capacitor. Once when this value it is overdriven by this value it will be erased and this value it will be taken. And again when this value it is overdriven by another peak value, then this value will be erased and this value will be taken as its output. The same circuit it can be used for detecting the negative peak also. The thing that you have to do it is just you have to reverse the direction of the PN junction diode which was connected in the positive peak detector circuit. By reversing the diode direction, you will be able to find the lowest voltage signal in the circuit. To conclude this discussion, a peak detector is a circuit which computes the peak value of the applied input. So here maximum peak value it will be stored inside the capacitor until the capacitor it gets discharged. So the role of this peak detector circuit it is just to compute the peak value of the input signal. So here the circuit it just follows the voltage peak of the applied input signal and stores the highest value in the capacitor, and it can be applied for the following application, namely test and measurement instrumentation, and it is also used in amplitude modulation for communication system circuit.